question. So before going to understand this question, just go through the previous video, how to apply KCL, how to apply KVL in KCL. Okay, then only you can understand how to apply KCL or nodal analysis. So in this question, I want to find current flowing voltage across 3 ohm resistor. So let it be. This is the question. Uh, by using KCL. Okay, by applying KCL, we have to identify voltage drop or voltage across a 3 ohm resistor. The 3 ohm resistor across 3 ohm resistor, we have to identify voltage. That is nothing but let it be V naught voltage across 3 ohm resistor. So to identify voltage drop across 3 ohm resistor, that 3 ohm resistance must be multiplied with current flowing through that 3 ohm resistor. Let it be this is IA. For example, I am assuming IA. So to identify V naught, first we have to identify how much current passing through 3 ohm resistor using KCL. So this is the target. So already in previous video lecture, I explained that how to apply KCL and what are the steps to follow while applying KCL. So first step is nothing but identify number of junctions. So by observing this electrical circuit, there are you can observe number of junctions in this circuit. Okay, for example, so let it be this is the point. So at this point, only two elements are connected together. It means the amount of current passing through this 4 ohms resistance is exactly equal to current passing through 1 ohm resistance. It means there is no current division at this point. That's why it is called as node. Okay, and also here it is. This point is also called as node because only two elements are connected together at this point. Okay, similarly at this point. So at this point, there are three elements. More than two elements are connected together. That's why it is called as junction. And at this point, this is also called as junction because there are three elements. One, two. So this entire portion is common voltage, equal potential. So that's why this is called as the junction. And this is node. So after analyzing this circuit, there are only two junctions. One is upside and another one is downside. Okay, let it be. This is the point one. So after identifying number of junctions, we have to indicate potentials. Let it be. This is V1 and this is V2. And I am assuming reference voltage as V2 and the reference voltage is equals to 0 volts. Okay. Now apply KCL at each junctions except the reference voltage. So this is a reference. Now we have only one junction, main junction. At this junction, we have to apply KCL. Before going to apply KCL, first we have to identify or indicate current directions at this junction. Okay, let it be this is I1, I2, and this is I3. All are outgoing currents. But you can also assume all are incoming currents or some of so few of them are incoming and remaining outgoing currents. Your wish. So after indicating correct directions, apply KCL at junction 1. According to KCL, sum of incoming currents equals to sum of outgoing currents at a junction. Okay, here there is no incoming currents, so it is equals to 0. And there are three outgoing currents, nothing but I1 plus, I2 plus, I3. Okay, Simply we can write it as I1 plus I2 plus I3 is equals to 0. Let it be equation number 1. So after writing KCL equation at junction, then we have to identify expressions for I1, I2, I3 in terms of junction voltages. Okay. Now the target is I1. Here I1 is nothing but current passing from junction V1 to V2 through through 1 ohm resistance, 4 volt voltage source and 10 ohm resistance. Draw that path as it is without any change. There is 1 ohm resistance, voltage source and 10 ohm resistor. This is 1 ohm resistor, 10 ohm resistor, 4 volts resistor, and this is V1 and this is V2. That thing but reference voltage 0. And current direction in this path is like this. So this is my current, assumed current I1. Now apply KVL for this loop. If you apply KVL for this loop, you will get minus V. So because since it is a starting point for the current path and this is end point, I am assuming starting point as negative and end point as positive. Okay, minus V1 plus 1 into I1 plus 4 volts plus 10 into I1 plus V2 is equals to 0 according to KVL. Here, the reference voltage V2 equals to 0. Then, after simplifying this equation, 11I1 is equals to V1 minus 4. Then, I1 is equals to V1 minus 4 divided by 11. Let it be equation number 2. Equation number 2. Okay. Now, second expression for I2. Expression for I2. What is I2? The current passing through the path uh, through a resistance 5 ohm resistance from V1 to V2. Draw that path separately without any change. So this is V1 and V2 nothing but equals to 0 and this is 5 ohm resistor. And current direction is like this from where to where V1 to V2. So this is my current direction, assumed current direction. Now apply KVL for this path minus V1 plus 5 I2 plus V2 is equals to 0. Here V2 equals to 0, then I2 is equals to V1 by 5. Let it be equation number 3. Okay. Third path, I3. I3. What is I3? It is also uh, passing from V1 to V2 through 2 ohms, 3 ohms resistance. Draw that path separately. 2 ohms, 3 ohms, and end at V2. So this is V1, 2 ohm resistance, 3 ohm resistance. And current direction is like this. So this is I3. Now apply KVL. After applying KVL, V1 plus 2 I3 plus 3 I3 plus V2 is equals to 0. Here V2 is equals to 0, then I3 is equals to V1 by 5. This is equation number 4. 4. Now substitute equation number 2, 3 and 4 in equation number 1. After substituting these three equations in 1, we will get V1 minus 4 divided by 11 plus V1 by 5 plus V1 by 5 is equals to 0. Okay, simplify this equation. V1 by 1 by 11 plus 1 by 5 plus 1 by 5 is equals to 4 by 11. Simplify. After simplifying these values, 11, 5, 5. So this is equals to 0.49 V1, 0.49 V1 is equals to 4 by 11 by 11, 0.3636, 0.3636. 3636. Then V1 is nothing but 0.742. Once again, I am checking 11, 5, 5, 0.49, and 4 by 11 is nothing but 0.3636 divided by 0.49, 0.742 volts. Okay, this is the voltage after solving equation number 1. So what is meaning of V1 here? Voltage at junction V1. Voltage at junction V1. And the reference voltage is 0. Okay. And our target is we have to identify voltage across 3 ohm resistor. What is voltage across 3 ohm resistance? Let it be V naught. Then that is nothing but V naught is equals to 3 into current flowing through 3 ohms resistance. So according to my current directions in this circuit, in 3 ohm resistance, I3 amount of current is passing like this. I3. Yes. Okay. Now voltage drop is nothing but 3 multiplied by I3. Here I3 is nothing but we got expression for I3. This is I3 V1 by 5. Then 3 into V1 is nothing but 0.742 divided by 5. Okay, solve this value into 3. 0.445 volts. This is the answer. Okay.